Oftentimes when we're using right angle trigonometry to solve problems, sometimes we're given these terms angle of elevation and angle of depression. And what that's referring to is we're introducing kind of a vertical dimension. And you could just imagine if you're standing and you look up, you tilt your head to look up, the angle off the horizontal that you're looking up, that's called an angle of elevation. And if you look down, the angle off the horizontal to the angle that you're looking at, that's called an angle of depression. This is a fairly simple concept, but it's very often missed by students when given the description of a problem. It's interpreted incorrectly. So I'm going to go through a whole bunch of these kinds of problems here, and we can kind of just get a sense for how this works. All right, the angle of elevation to the top of a tree is 30 degrees from a point 28 feet away from the base. Okay, so I don't have brown, but here's a red stem tree with, oh, I clicked the green, there's a tree, and 28 feet away on the ground, so this distance is 28 feet. The angle of elevation to the top of the tree, meaning if this is the line of sight looking up to the top of the tree, this angle right here is 30 degrees. That's what that tells me. It's off the horizontal. I had to look up 30 degrees to see the top of the tree from standing 28 feet away from it. So if I want to know the height of the tree, well, I just use right angle trigonometry, because we're assuming this tree has grown vertically. The sine of the 30-degree angle is equal to the tangent of the 30-degree angle is equal to the height of the tree that I don't know, right? I want to know what this is. That's supposed to be a question mark, divided by the 28 feet. Okay. Now I know that the tangent of 30 degrees is root 3 over 3. So this is 28 times the square root of 3 over 3. You could just plug it in your calculator too. And let's see, what is this? This ends up being, and I'm not going to go through and actually show you how to plug in the calculator. Just hit 28 times the tangent. Oops, 28 times the tangent of 30 degrees. And you'll find that this tree is about 16.16 feet tall. Alright, let's draw a picture of this one. We have this guy, John Hosmer, and he's pretty tall apparently. So here's a flagpole, and the ground is here, and his eyes are 15 feet above the ground. So here's the guy, and his eyeballs are 15 feet above the ground. He looks down at the bottom of the flagpole through an angle of depression of 10 degrees. This is 10 degrees. He looks up to the top of the flagpole through an angle of elevation of 27 degrees. So this here is 27 degrees. And he's 100 feet away from the flagpole, right? So he's 100 feet away. And we want to know how tall is this flagpole. So we want to, well, it says here that we don't know that the level, the bottom of the flagpole and Hosmer speed are the same level. Just assume that they are for this problem. So we can say then, there's a few things we can do. First of all, we're going to need to basically break this down into two heights. Like, let's call this like height sub 2, and this will be height sub 1. And we have enough information to find each of them independently, because we could just say that, by the way, the way you would solve this if you didn't know he was on the same level as the flagpole, you do something called the law of sines. But we don't have that available to us right now. So we could just say then that this height right here, right, is h2. We can solve that. Well, let's solve that one first. I don't know why, whatever. So with respect to this 10 degree angle, we know the adjacent side, it's 100, and we know the opposite side, which is, well, we want to know the opposite side was h2, right? So we could say then that the tangent of 10 degrees is equal to the opposite side h2, which I don't know, divided by 100. So h2 is equal to 100 times the tangent of 10 degrees. So we'll plug this into a calculator later. Now h1, similarly, like with respect to this 27 degree angle, we know the adjacent side and we want to know the opposite. So for this one, we say the tangent of 27 degrees is equal to h sub 1 divided by 100. So h sub 1 would be 100 times the tangent of 27 degrees. And so all we're going to do is add the tangent 100 times the tangent. We're going to have 100 times whatever the tangent of 10 degrees plus the tangent of 27 degrees is. I just like factored that. So what is that? Let's check. That is, I'm just going to write this in the calculator really quick, sorry. So tangent of 10 plus tangent of 27 times 100. So if we round that up to the nearest foot as suggested in the problem, this is equal to 69 feet. The flagpole is 69 feet tall. Nice. From the top of a 70-meter tall building, the angles of elevation and depression to the top and the bottom of a taller building across the street. So here's my shorter building, 70-meter building. Then here's my taller building. This is obviously not drawn to scale. I don't know any of the values here. But it's across the street, and the angle of elevation to the top, like so this angle right here, this is 50 degrees. And down to the bottom here like this is 35 degrees. That's what that says there. So find the height of the taller building. So this is very similar to the previous problem. I need to know h sub 1 and h sub 2. I know h sub 1, don't I? H sub 1 is 70 meters, right? If it's straight across 70 meters. So that's not what I need. What I don't have here is the distance, how far is this across the street? But I can find that because with respect to this 35-degree angle, I have the opposite side now, and I don't know the adjacent. So no problem. If I want to do that, I just say the tangent of 35 degrees is equal to the opposite side of 70 divided by this distance, let's call it x, across the street. This distance is x. So in this case then, x is going to equal 70 divided by the tangent of 35 degrees. So that's it. I don't actually need, in order to solve this problem, because it only wants the height of the taller building, I don't actually need to know what that x value is. Like I can just keep that in my calculator the whole time. I don't have to state what it is. So now I know x, it's known, right? I don't know h2, but also I know that the total height of the building, h, is equal to h2 plus that 70 feet, right? So in that case, what would h2 be? Well, h2, I don't know. It's the opposite side with respect to this 50-degree angle. So I could say tangent of 50 degrees, and notice we're using tangent very often here. Tangent of 50 degrees is equal to h2 divided by x, which we know x, right? So h2 is equal to x times the tangent of 50 degrees. So we know h2, so basically what I'm going to do is h is equal to, right, x we said was 70 divided by the tangent of 35 degrees, and we're going to multiply that by the tangent of 50 degrees, and then whatever we get, we're going to add 70 to that. So let me just plug that into the calculator real quick. 70 divided by the tangent of 35 degrees times the tangent of 50 degrees, and then add the 70. So the height of this building, the height of the taller building, is 189.14-ish feet. Okay, so there's a blimp. The name of this blimp, it might be, we don't know for sure, but it might be Blimpy McBlimperson. It's hovering in the air at a height of 500 feet, lies directly over a line from Soldier Field, so that's like a stadium, so let's say there's your Soldier Field. I think that's where the Bears play. And then there's another thing like a planetarium, I don't know what it looks like, let's say it looks like that. And basically what we have here is this height is 500 feet, and the angle of depression from the blimp to the stadium, so this is the blimp's like line of sight, and down to the stadium here, this angle of depression right off the horizontal is 32 degrees. It also says that to the planetarium, so again this distance, this angle of depression, this is 23 degrees. We want to know what is this total distance from like here to here. So what is x? What is this equal to? And so we can do this. This is just like the previous problems, and you have options for how to do this. What I might recommend for this problem is absolutely not necessary, is to realize that you can kind of have two right triangles here. And if you have a 23-degree angle here, that means like this is also a right triangle, so is this. If you have this is 23 degrees, then that means the complement to 23 degrees is 67 degrees. And the complement to 32 degrees is 58 degrees. And so now you can say, all right, well, with respect to this 67-degree angle, I know the adjacent side, it's 500, and I don't know this opposite side, which we'll call x2. And with respect to this 57-degree angle, I know the adjacent side, but I don't know the opposite side, which we'll call x1. So if x is equal to x1 plus x2, then all I need to do is find what x1 and x2 would be. So we can say that and I'm looking at tangent here, the tangent of 67 degrees is equal to the opposite side, x2, we don't know, divided by 100. In other words, x2 is equal to 100 times the tangent of 67 degrees. Oh, is it 100? 500. What am I saying 500? What am I saying 100 for? Okay, so that's that, and I hope by the same process you can see that x1 would just be 500 times the tangent of 58 degrees now. Okay, by the exact same procedure. So x, the distance between these two things, is just going to be 500 times whatever the sum of tangent of 67 degrees plus the tangent of 58 degrees is. All I'm doing there is factoring out of 500 from the math, so I don't have to write the number 500 more than once. So what is 500 times the tangent of 67 degrees plus the tangent of 58 degrees? That is 1,000, so it is 1,978.1 feet. So those two things are 1,978.1 feet away from each other.